If you invest $4,000 in a mutual fund that earns 3% annual interest, compounded monthly, how much money would you have after 5 years? And they give us the compound interest formula is A is equal to P times 1 plus R over M, and all of that to the MT power. And we could just apply this by plugging in these numbers. But one thing I do want you to realize is that this is not just some magical formula. It's actually very, very straightforward to derive, and it's actually a common sense formula. I think that's important because when you have to figure this out, when your mutual fund manager is talking to you, you probably won't have this formula at hand. Or even if you do have this formula, you have to know when it makes sense and when it doesn't make sense. And to show that this is actually fairly straightforward, just think about what happens if I start with $4,000. If I start with $4,000 and I compound it once at 3%. So here, when they say compound monthly, what they're really saying is every month you get to compound your money. You get to grow your money by 1/12 of 3%. But let's say we have a reality where we're compounding annually. So let's say compound annually. So that means every year you get 3% more than the money that you had going into the year. Compounding annually. So you're going to start with $4,000, and then after 1 year you're going to get 3% of $4,000. So 0.03 times $4,000. This is after 1 year. This is the same thing as $4,000 times, if you factor out the 4,000, 1 plus 0.03. So you have your original principal amount, and if you compound once annually, you get that times 1 plus your actual annual interest rate. Now, if you were to compound annually 5 times, you would then compound this by 1 plus 0.03 times 1 plus 0.03. And the only reason why I'm not just writing 1.03 is so that you see how it relates to this formula they're giving to you. And if after 2 years, if you compound annually, you'll do it again and again. So really, if you do it for 5 years, you're going to multiply this times 1 plus 0.03 5 times. So if you compound annually at 3% over 5 years, then you're actually just looking at $4,000 times 1 plus 0.03 to the 5th power. And I think you already see this is how much you would have left after 5 years. So this is what you would be left with. And I think you can already see the pattern relative to this formula. You have your original principal amount, $4,000. You have the 1. Over here you have your rate. Over here we don't have any M because we're compounding annually. M is the number of times you compound per year. And once again, we just have the time 5 years. And over here, in this case, you could just say that M is equal to 1. So let me write this. This is the case where M is equal to 1. Let's think about what happens if we compound every 6 months. Because I really want you to get the intuition for this formula. Compound every 6 months. Or you could say twice a year. So you start off with $4,000. After 1 6-month period, how much are you going to have? Well, every 6 months, you're going to compound half of 3%. Since we're compounding twice a year, each period you get half of the annual interest rate. So after 1 6-month period, you'll have 1 plus 0.03 over 2. After another 6-month period, you'd compound that again, 0.03 over 2. And so how many 6-month periods are we going to have? Well, 5 years has 10 6-month periods. So this is going to be equal to 4,000 times 1 plus 0.03 over 2 to the, we have 5 years, each of them have 2 periods, 2 times 5 power. And now you see it directly. Our principal is right over here. It's $4,000. Our annual interest rate is R. It is 3% in either circumstance. And the number of times we compound per year is M. Now let me do that in a new color. It is M. The number of times we compound per year is M. In this case right over here, it is 2. And then the number of years that we are doing some compounding is T right over there. So hopefully this formula makes sense, and you see it's not just coming from some financial voodoo. It actually comes straight from common sense. But with that out of the way, let's think about the actual question. If we invest $4,000 in a mutual fund, so we want to solve, if you invest $4,000 in a mutual fund, so now let's think we're going to compound 12 months, or we can say 12 times per year, because we are compounding monthly. Every month our money will grow by 1/12 of 3%. So it's going to be 4,000 times 1 plus 1/12 of 3%. And then we're going to do that to the number of years times the compounding periods per year. So we have 12 compounding periods per year times the number of years. And just to see where it all fits in, this right over here, $4,000 was our principal. That goes right over there. That is P in our formula. Our rate is 3%. That is R in the formula, and hopefully the formula makes sense to you now. M, the number, when they say compounded monthly, they're telling us that we are compounding 12 times a year. Compounded, let me do that in that right color. Compounded monthly, this tells us that M is equal to 12. M is equal to 12, right over there and there. And then we are doing it over 5 years. We are doing this over 5 years. That is our T. That is our T right there. And now we can just get a calculator out to actually evaluate this. Let's see. We have got my trusty TI-85 out. We're going to have $4,000 is what we're starting with, times 1 plus, and then we have 0. Or we could just write I'll just write the 0 out front just to be clear. 0.03 divided by 12. So that's how much we're going to compound every month. And then all of that to the 12 times 5 power. Actually, let me make it clear that, we want to do the order of operations. So let me insert a multiplication sign, and then let me raise everything in parentheses to the 12 times 5 power, or to the 60th power. And it might seem like a very huge exponent, and it is, but remember, you're taking 1 plus a very small number to the 60th power. 1 at the 60th power would just be 1. The closer you get to 1, the more times you can take its power without it becoming a really huge number. But we want to be clear, we want to take this to the 60th power before we multiply by 4,000. And we get $4,646.47. Let me put this over the side so I can read it. So this gives us, if we invest our money, and this is what's pretty neat, that 3% compounded monthly, 3% annual interest actually does add up to a good bit over just 5 years. 3% doesn't seem that exciting, but adding $4,646, so adding $646 to $4,000, that does actually seem pretty exciting. And if we round up, 47 cents is what you would have in your account after 5 years.